Hello, everyone.
Hi.
I think it's
Hello.
the rare times where we have so many people on screen together with us. Thank you, everyone, for joining us. Whether you are tuning in from Singapore, it will be Saturday morning. And if you are tuning in from Mexico, it will be Friday night. Yeah, so we hope you are having a great day wherever you are. Do let us know where you are tuning in from. And I'm Jiaxing from the Google Developers Relations team. We are super excited for today's session. It's our first collaboration with the Go Mexico team. And we have, I think most of you would be familiar with the Go Singapore team. And before we begin today's session, let me just briefly introduce what Google Developer Space is. So it's a platform for developers and startups from around the region to learn and connect with one another. And as part of the developer relations team, we aim to connect our community to our people, programs, network, and technologies. So without further ado, I'll hand the stage over to Tekton from Go Singapore to introduce more about himself and the team. Tekton, over to you.
All right. Good morning. I hope my voice is okay. No echo. Good morning, everyone from Singapore. Como esta?
Good morning.
Hello. Nice to meet you all. Good collaboration. Today we have a lot of two speakers lined up. I think before we go to the main topic, let me introduce the team a bit, and I'll hand over to Rodolfo for the introduce of the Go Mexico team and the speaker. And from GoSG, myself is Tekton. I help to co-organize the GoSG meetup, Golang Singapore. Thank you for supporting us for the past 1 year. We've been going online since March last year. Right? Thank you very much. And thank you to all the speakers who have spent time with us, sharing your knowledge. Today we have Stanley, also from the GoSG team. Hi, hello Stanley. Yeah, Stanley, I think is a familiar face in the Singapore circuit. Right? He's been with many communities, right? So you should see him quite often, right? And we're Abel on the way. His video. Abel is also a co-colleague in SP Digital, right? And also a very active tech community participant and leader. Right? And we are Siu Yin today from GoSG for our second speaker. And Siu Yin will share with us today about an always up-to-date and testable documentation. And
problematic documentation.
Okay. Right. All right. Without further ado, I'll hand over to Rodolfo for you to introduce the team, the speaker. Over to you. Thank you.
Yeah, thank you. Hello, everyone. We are glad to collaborate with Go Singapore this time. We are Golang Guadalajara, a Go community from Mexico, and we are Gustavo. Hello, Gustavo. A software developer in Mexico, and Guillermo, our speaker. Hello, Guillermo.
Hi.
So we are very glad to collaborate this time, and we are in many social networks. As you can see in the slide, we are on Facebook, Twitter, GitHub, Slack, Meetup, and YouTube. Also, we have an open collective if you want to support us. So if you want to follow us, we will thank you. And there in our social networks, we are broadcasting our next meetups. So thank you for the collaboration, and we can continue.
Thank you. Without further ado, I think the first speaker will be from Go Mexico. Over to you, Guillermo.
Okay. Do I start?
Yes.
Okay. Hi, everyone. Thank you very much to be part of this session. My name is Guillermo Galvan. I am from Guadalajara, Mexico, and I am working as a Golang developer at TechBridgeIT. Well, a little about myself. I am a mechatronic engineer who recently started working on the software industry. I started as a web developer for a chatbot project where the API of the chatbot was written in Go. And later, a couple of years ago, I was working for another company as a DevOps. Therefore, I started to learn more about cloud technology, orchestrators, and microservices. Well, this session is going to be about how to build a CI/CD tools with Go using Kubernetes. It's more likely like playing around with Kubernetes and Go. It is basically a tool that interacts with Kubernetes and deploys a new version of an application once the developer made a change into the application repository. The application that I will use is GitHub. And I also, for building my pipeline, I will use GitHub Actions. Well, before we go into the demo and the details, I would like to share you a topic that encouraged me to work on this, and that is GitOps. What is GitOps? GitOps is a way of implementing continuous deployment for cloud-native applications. It focuses on the idea of using tools that developers are already familiar with, like Git and continuous deployment tools, and also on spend more time in developing than in configuration stuff. The core idea is not only to have your application in a repository, but also have your infrastructure state in a repository as well. As we can see in the image, we have the code base for our application, and also we have a config repo for our jams. So each time if there are a change in the infrastructure repo, then automatically the infrastructure will change. Okay. For this, we have two ways where it can be implemented. The first one is called push-based deployment. This kind of deployment can be implemented by your popular CI/CD tools. That is like Jenkins, CircleCI, or TravisCI. The way it works is that we have our infrastructure jams and our application code in the same repository. So whenever there is a change on the application repo, then the build pipeline is triggered. After that, if pipeline succeeds, the image of our application is pushed into the image repository, and then the environment is updated. We can think of our environment repo as our deployment manifest or how the app will be deployed. Once the environment repo is updated, then the deployment pipeline is triggered and a new version of the app is deployed into the environment. One thing to keep in mind is that the deployment pipeline is only triggered if there is a change. All right. So next one. The second one is pull-based deployments. In this approach, we have the same concept of push-based deployment. It is only different in how the deployment pipeline will work. Here, the operator is introduced. What the operator does is to compare the desired state of the environment repository with the actual state of the deployed infrastructure. So whenever there is a change on the environment repository, the operator updates the infrastructure environment in order to match the environment repository. Additionally, the image registry can be monitored to find new version of the image to deploy. As we can notice on the image, the operator live in the same environment as the application. Well, so we have seen about GitOps and two ways that it can be implemented. Nowadays, we have already some tools that work on this. One of them is Argo CD, the other is Jenkins, and then we have another tool that is very popular, that is Flux. Okay, so now it's time to see how can we start to build an application that interacts with Kubernetes using Go. But first thing first, what these tools have in common is that they all communicate with Kubernetes. How can it be possible that? Well, I will show you for this two ways. But first, I'm going to talk about the first one, that is about, we are going to see first a big picture about Kubernetes. Kubernetes is made up of a bunch of nodes with different roles. Some of them are part of the master node, and some other nodes are part of the worker nodes. We have the control plane on the master node. That consists of the API server, the control manager, and the scheduler. Now, the API server is the central entity and the only component that talks directly with the distributed storage component, HDCD. The responsibilities of the API server are to serve the Kubernetes API and to proxy cluster components. This API server, it is used internally in the cluster by master component, the worker nodes and Kubernetes native apps, and also as well as externally by clients as kube control. Okay, so far we can see here that the heart of Kubernetes is its API server. But how does it actually works? Well, from a client perspective, the API server exposes a RESTful HTTP API with a JSON or protocol buffer payload. The API server interface handles HTTP requests to query and manipulate Kubernetes resources. We have here like the following HTTP verbs that Kubernetes server handles. The get verb is used for retrieving data with a specific resource, such as pod, for example. And also, it retrieves a collection of a list of resources, for example, pods in a namespace. We have post verb that is used for creating a resource, such as service or deployment. Put is used for updating an existing resource, like, for example, changing the container image of a pod. And patch is used for updates of an existing resource. And finally, we have delete, that is for completely destroy a resource. Well, now we're going to see a little terminology here for the API server before we go into one example. There are some concepts for this that are objects, kind, API groups and resource, and version. Now, let's talk about objects. Objects are the persistent entities of Kubernetes. Examples of these are the pods, namespace, replication controller, deployment controllers, stateful sets, volume. After objects, we have kinds. Kinds represent the type of object created. There are three categories of kinds. The objects that represent the persistent entity in the system, for example, a pod or an endpoint. Next one is lists, that are a collection of one or more kind of entities. Normally, lists have a limited set of common metadata, for example, pod lists or node lists. And finally, we have special purpose kinds that are used for specific action on objects and for non-persistent entities as binding or scale. Well, we have also groups. API group is a collection of kinds that are logically related. For example, all batch objects like a job or schedule job that are in a batch API group. They exist several types of groups. For example, here I demonstrate two, the core group and the naming group, that we will play around with them in the code later. Okay, now, resource are the name used in the URL. They correspond to HTTP paths, where are usually lowercase and also plural words that identify a set of HTTP endpoints. Also, as we can see, they are always part of the API group and version. This collection that we can see here is referred as a group version resource. And finally, we have versioning. Kubernetes support multiple API versions for extensibility reasons. Here are the different parts of versioning. We have the alpha level that is usually disabled by default. We have also the beta level that is enabled by default, and that means that the code was already tested. And also, finally, we have the stable level that will appear in release for many subsequent versions. Okay, so let's play around. Let's see the console after these slides. First, we are going to run the command for proxy. Okay, I'm gonna run it right here. Control port 8080. Now, what this command does is to proxy the Kubernetes API to our local machine, and also it takes care of the authentication authorization. It allows us to directly issue a request via HTTP and receive a JSON payload in return. First, I don't have any resource yet on my cluster. I am running a cluster in GKA. So first, I'm going to run that. Let me show you what I'm going to do. It's going to be something easy. It's going to be just one pod running. This is on the deployment example. So let me see. It's here, yes. Kubectl apply f deployment example. Okay, that is created. We can see it. First here, get pods. I have it in a special namespace. Okay, I have one pod running. Now, let's see a way to interact. One way for doing this is with a core command. So I'm going to hit, we are going to hit our API server. Here is local host. In this case is 8080. Now what we are going to first is the group API. Is the version V1, the stable one. We are looking for a specific namespace. Namespaces. The namespace is test demo, and it's again in order to get pods. We are listing the pods. Here. Let me remove this. We hit it, and then we got the results. So it's just a little example of how we can communicate, that is running and starting our own proxy. You might be wondering, so okay, in Go, I just create a client and communicate like that. Well, in practice, there is a better way in order to interact with Kubernetes. Now, we are going to start working on the Kubernetes programming interface in Go. The Kubernetes project, let me show you the slides. The Kubernetes project provides a number of third-party libraries on the Kubernetes organization and GitHub. As we can see, the three most used for trying to interact with Kubernetes are Client Go, IP Machinery, and API. The three are part of the Kubernetes organization. So, okay, we're going to talk about Client Go. Client Go is a web service client library that supports all API types that are officially part of the Kubernetes. It can be used to execute the usual REST verbs like create, get, list, update, delete, patch, and additionally, we have the verb watch that is for watching for the events that are occurring for that specific resource. Client Go is available on GitHub and it is shipped in parallel to Kubernetes itself. That is, for each Kubernetes 1.x.y release, there is a Client Go release with matching tag Kubernetes 0.x.y. As we can see, the major version will remain in 0. What is included in this package are the Kubernetes package that contains the client set to access to the API. Then we have the discovery package that is used to discover APIs supported by the Kubernetes API server. Then we have dynamic package that contains the dynamic client that can perform generic operation on an arbitrary Kubernetes. We are going to see about that package later on. And then we have the out package that contains the optional authentication plugins for obtaining the credential for external resource. Then we also have the transport package that is used to set up and start a connection. And finally, we have the tools cache that it is useful for writing controllers. Okay. So next we have the Kubernetes API and also machinery. The Kubernetes API, it is the schema of the external API types that are served by the Kubernetes API server. It contains the Go types for objects like pods or namespace. Specifically, they can be found on the API core v1. Inside this package, we have also other files that are mostly generated from a code generator. This is something important. Some of that files might be generated from a code generator. That's something that Go have that makes us easy. Then we have the API machinery repository, where we have all the generic building blocks to implement a Kubernetes API and to work with the API infrastructure without type of any dependency. Okay. Well, enough with the failure theory for the presentation. So, well, now that we have the building blocks to create a Kubernetes client object, we are going to take a look into the code. Yes, I am going to show you a little example. First, I'm going to stop this. Okay, this is the example. What this example will do is to list all pods that contains the label app hello. For this, as you can see, I only have I just create one pod, but it doesn't contain the list label. So I'm going to create another one. This is my Jam file where this is the app hello label, and I'm going to create 3 replicas. So my program will be able to read that pod. So first, let me create that. I have like this. So okay, this seems to be up and running. Oh, yep, too fast. Yes, it's on Linux. All right then. So first here from the import, the code imports the Meta v1 IP machinery package to get access to the Meta v1 list options that we are going to use. Then imports the client Go Kubernetes package with the client sets for Kubernetes resource. Also, we have import the out package that contains the authentication for obtaining the credential from the Google Kubernetes engine. Therefore, it imports the client CMD from the client Go in order to read and parse the kubeconfig. Now, this is the part where we have the kubeconfig. From the client CMD build config flags, we get the rest config, which you can find in the Go client rest package. And then this is passed to the Kubernetes new config in order to create the actual Kubernetes client set. This is called the client set because it contains multiple clients for all native Kubernetes resource. Then we make use of the meetup v1 from machinery in order to do the label selection. Let me see. And then we have the selection here. And we select the core group B1 with the client set core B1, and then access to the pods located on test demo namespace. And then we follow with list. It's most likely like the building pattern, where you are constructing the resource, and then you make use of list to do the get call. Well, so let's see if it works. It is actually, if we were going to do the a pull request, this is something more look like. So, well, let's run this. Go run hello pods. Please works. Yes, it works. Okay, so we have our first interaction with Kubernetes using the ClientGo library. Okay, let's go back to the presentation. There is another topic that you must know. Since Kubernetes is backward compatible with clients, the old ClientGo versions will work with many different Kubernetes cluster versions. Here I am showing a table that illustrates the compatibility. The checks means that they have the same feature in both ClientGo and the Kubernetes version. The plus means that the ClientGo has features or API objects that might not be present on the Kubernetes cluster. The minus sign means that the Kubernetes cluster has features that the ClientGo has not. So this is something that you should take. So, well, now that we have some foundation in order to build our tool, let's see how it looks. I'm going to show you the tool that I do for this presentation. Okay, I'm going to explain. We are going first, let me share. Here it is. First the program. I'm going to run the program. It is here. No. It's here. Here. Alrighty, seems to be working. So what I'm going to do is, first I am like emulating a workflow where I will be working on this example application that is written in Go. So what this app do is it just print a hello world. This application will be managed by my GitHub actions, and then that GitHub action, what it's going to do is to trigger an event to my service that I have here, and then once it is triggered, I'm going to create a new deployment with the new version that is specified here. So let's play here around to see. For example, let's say that we are working on this project, and suddenly this hello world, you will say, I'm going to print out that this is going to be version 16 instead of 15. So imagine that we are using Git and your favorite code editor, but in this case, for the example, I will use this. It's a little bit more faster. And so imagine we are not going to commit directly to master. We are going to create our pull request for that. Propose a change. So imagine that someone will saw and we say, okay, it is okay. So create the pull request. And then once the pull request is done, well, we are going to trigger a job in order to see that it is working. Imagine that is our CI system. So once it is done, so we can make sure that it is ready. So we are going to wait. Okay, green was successful. So that means that it had my approval. So I confirm the merge, and then it goes to master. Okay, so far, so good. It goes to the master, and then we have the this new version. And also, we trigger another one just in order to make very, very, very sure that it is working. So once it is green, we are going to do a release of our version. So imagine that you are using Git and you are going to do it in the command, or you can simply do it here. So just waiting that this is green. If it's not green, is that something bad happened? It's mostly the same as the branch. It's just doing stuff. So let's do a new release. We edit the release. No, sorry, edit no. I mean create a new one. Release, draft a new release. Okay, so here we go. Our version is 0.0.16. We are agree. It's the new version of our application, and that thing I would like to have it deployed right now on my cluster. So let's publish and release. Okay, it is on. Once, okay, here we go. What it does now is that this build pipeline will do the same step like here, just making sure that it's working. And also one additional steps, we are going to push the new image to Docker Hub in order to have the image available once we have once it is required by our clustering on Kubernetes. So we are going to wait a little in order to have this. Please, be green, work. And well, when this finish, it will actually. Okay, it works. Okay, it finished the build, and if we can see here, we have the new version 0.16, and we have our example that was able to deploy a new version here on our environment. And well, how does it work? We just see, let's see on code how that works. So, well, first, this is the main. Well, as you can see in my configuration for my config, we are doing pretty much the same as the other example. We're starting the server. We are saying that in this path, we are going to receive the GitHub action events, well, a little of dependency injection in order to have available the Kubernetes API. So here is where the magic happens. We have first, we get the tag and status. And once it is valid, we go to the part where we deploy the application. That is right here. And this is how it looks like now. Well, here I'm just creating a new name. The thing that I'm doing is just replacing dots for slashes for the name of the pod new created. As we can see here, we first create a new deployment struct where we define what will be the attributes. In this case, will be 2 replicas. It will be pulled from this Docker repository, and we are going to assign the tag. And once it is create the deployment, once it is filled that struct, we create the deployment. So we are pretty much using the same meta v1, client go, well, GCP authentication in order to do that. So, well, that was good. So we can make sure that it is running. I told him that in the test demo it will be. So we have here test demo. We can do pretty fast just a port forward in order to see that it's running. Port forward this on the 8080. I have already that one. I think that one too. Let's see, port forward down, code port forward. Okay, misspelling here. Deployment not found. Well, never mind. Anyway, I forget how to do that, but no worries. We have here that it is running. If we do just port forwarding, it was just for showing that it was running here, and we were just viewing the new version of the app. So, well, let's continue with the talk. There is a little bit more, because what if we have something more like it's not like the generic resource of Kubernetes, like deployment or like pods or something like that. Let's say we have running something like Istio, or we have Tekton on the cluster, and I would like also to interact with them. Where here is where we are going to see about custom resource definitions. The custom resource definition are a very powerful Kubernetes feature, which allow us to create our own first-class resource like pods, deployments, services, and then it can be possible to interface with them using the kube control or the Kubernetes API. So, how can we work with CRDs in Golang? There are 2 ways. One is creating the strongly defined types, which you can use to interface with the CRDs. And the second one is using the dynamic client from the client Go, which allows you to access quickly to the data. And also, you don't have to write a lot of code. I have prepared an example for this. I'm going to show you how to communicate with an open source project called Tekton. In a very few words, Tekton is an open source framework that allows us to build, test, and deploy our code. The components on Tekton are pipeline, triggers, dashboard, and more. So, just like a quick overview, this is our Tekton system. It's a CI/CD tool, and where you can define pipelines, pipeline rules, tags. I was playing around with it, and well, it worked. So, in order to communicate to that custom resource, I made an example here. Hello CRDs. In order to communicate, it's pretty much the same, but here we introduce the dynamic client. That is on the client Go. And another library that we import is the schema, that it can be found in the API machinery runtime schema. So the other thing that you must know is the group, the version, and the resource of the custom resource. So with this structure, now you will be able to list, get, or create your resource. So here in this case, we have list. We have another one. We have list, create, delete, and so on. So in this case, it must show just one pipeline. So let me clear out this. Go run hello CRDs. Nice. We list. We have, okay, I already have another one in the default namespace, and I have another one that in another namespace that I already said. So there is another way for accessing the CDR, is the hard way. The second one is is to create a Golang client for that resource. I'm not going to go into a very detail on this, but the steps are: first, you define the types of your custom resource definition. Then you have to create the deep copy files and methods. Register that types as such the scheme builder. Then you build the HTTP client and build the informer. These are the steps. And also another step is that you can take an existing code of that resource. Also, I have here an example where I just got the Tekton controller. Let me see. Every vendor will have his controller. In case of Istio has, I think, his own client Go, if you want to take a look later of that. Well, I'm going to, when developing code with Kubernetes, we're going to see two more concepts that are controllers and operators. About a controller, you can think about, for example, when you are controlling the temperature of your room in your house, where when you set a temperature in your thermostat, then the system will try to reach that temperature. So this is like it works as controllers. What it tries to do is to get to the desired state and stay right there. For example, when we say that I just want to have 3 pods, the controller will look for that and will be trying to have that. Another concepts are the operators. Operators are controllers, but they are very specific purpose. Normally, they are custom resource definition, and well, they are just very, very specific for what they want to control. For example, it is mostly used for database, like, for example, CorpusDB or Postgres or another one, where you want to specifically that it will run in a specific manner. So the operator will try to have the controller in order to have running that good. Sorry. Okay, actually, there are frameworks for that facilitate us to work with controllers and operators. One is the Operator SDK, and the other one is the Kube Builder. So this is pretty much of the talk. Thank you very much. I think it will be everything. So if you have anything, any concern or whatever, I will try to share my slides. I will try to share my mail and my GitHub in order to you also take a look. So thank you very much. I think that's all. I stopped sharing.
Hi. Okay. Thank you, everyone. Thank you, Guillermo, for sharing. There's only one question, though, but it's probably answered. Alfredo was asking, where do we add a test for the deployment? Yeah.
The test for deployment. Okay. Yes, The test for the deployment. Now that you mentioned that, I'm not very sure. I have seen that before, but I'm sorry. I just I don't know very much about it.
Yeah, no worries. Yeah, I think there's something maybe
But it's
we
very
can add on.
important that yes.
Yes, to the project. Yeah, no worries. Okay, let me see if there's any other questions.
Okay. Thank you.
Yeah. All right. If not, thank you, Guillermo. Thank you for sharing. And thank you for your time for the evening. Thank you very much. Yes.
Okay.
Okay. All right. Thank you. Without further ado, let me invite second speaker, Siu Yin. Siu Yin will talk about always up to date and testable documentation. Right. I think is I know we have Go Docs, but those document function, documentation for the functions, not how the system is assembled together. So today, Siu is going to share with us a productivity gain. Right. So I hope to also gain from this and help me solve a lot of my problems. Thank you, Siu. Over to you.
You're welcome. Okay, so today I want to talk about a very mundane, but I feel important topic, which is documentation. Most of us will document using README files, and README files tend to go out of date. For example, here's a README file, super simple one, and it says this code performs function A. Well, actually, in the code, it does perform function A, but as business grows, new functions are added, function B is added, function C is added, but because of time pressures, nobody bothers to update the README. So it just says the code performs function A. Sometime later, the business evolves and function A is no longer relevant. So it is refactored out. But the README still says the code performs function A. So the author of this README is not trying to lie to you. It's just that time pressures prevents him from updating it. And eventually, over time, READMEs will lie to you. So what can we do about it? We need a tool that can document the code itself. Now, of course, there is such a tool. Of course. Many tools, in fact. Go has GoDoc, C++ has Doxygen, Java has JavaDoc, you name it. We've got tools there. However, of course there's a however, but before the however, GoDoc is a very useful tool. So in order to get it into Go, that's why I like Go so much. You enter one single command, that command, go get, and you put the Go bin in your path and you have GoDoc. But now let's talk about what's the problem with GoDoc. What are its limitations? Let's look at a typical main.go. It's called example GoDoc. Here's the main function. We have a private function here. It's private in Go because it starts with a lowercase. And it calls a library function. Library functions in Go are called packages. So this library function is called myPackage. Capital A function, that's a public function. And the implementation for this private function is here. So let's run GoDoc and let's see how it documents main.go and the library function. I'm just going to copy and paste into my terminal. My terminal is in here. Actually, I ran it already, but I'll do it again. So when I run that up, it's exposing on port 8080 and it's in module mode Go has a very powerful module system. And AT. Okay, it's the Go doc. I need to look for my package, so I do Control F to find it. I'm looking for my package, Siu Yin. GitHub Siu Yin. This is today's presentation, and I'm looking at example Go doc. Let's see how well it is documented. I think something went wrong. Let me go back again. Reload by pressing F5. Okay, I've reloaded it. Let's look at Go doc again. Oh, still empty. Well, actually, I expected it to be empty. It's not a demo hiccup. So it doesn't document main.go. How about this? My package A function. Let's look at it. Go back. I have my package here. My package. Nice documentation. A function. Click on it. Yay! It properly documents a function. So, what have we just seen? GoDoc does not document main functions at all. However, library functions, my package public function, capital A func, was properly documented. But this private function, A func, this one, I'll go back, this function with this implementation was not documented. Of course, you say, it's private, and private functions should not be in the official documentations. Oh, okay, I'll take that for now. I've been looking at a lot of code bases recently, and I sometimes see this kind of main function. It normally comes about when people come to Go from Node.js or some other framework where the framework just calls the framework main function, typically the app function. So anyway, I have function app in here, and it calls in my package, I mean, and it calls two private functions. So let's look at the Go doc for my package app. Let's go up. It's my package app. Hey, app implements the application. Okay. Is that all? That's not very satisfying. GoDoc has a secret weapon. See this? I can see the source. Hey! Function app has private functions A func and B func, and they happen to be placeholders for now. Well, it's a convenience. It prevents you from needing to call up your editor and dive into the code base itself, and it links to the code. Fine. Yeah, better than nothing, I guess. But it doesn't leave a very good feeling. The documentation doesn't seem right to me. So now I'm hearing in my mind all of you screaming, saying, of course, you need to expose public functions. Otherwise, it won't be documented. You haven't refactored your code. Yeah, you need to expose them as public functions. But I ask you, who, in honesty, on their first try, completely implements a main.go with package public functions? Most of us start by writing local private functions and then refactor. That's the and then refactor is a big problem. We're all in high stress jobs, high speed jobs. When do we refactor? Big question. So sometimes to make your intent clear, you need to document your implementation details. In other words, your private functions. And as you can see, GoDoc will not show you private functions unless you dig into the code. What can we do about this very depressing situation? I thought about it for a while, and here is what I'm thinking. In order for documentation to be useful, our documentation intent must coincide, must be expressible by your code implementation. One example of this practice is Jupyter notebooks. Let me show you a Jupyter notebook. This is a Jupyter notebook. As you can see, this is documentation. It's got text, it's got links, and it's got code, implementation code here. The structure of the document, your documentation intent, and the code is all in one place. It's all documented at the same time in one place. But Go is not a notebook language. Neither is Node.js, neither is Java, neither are most traditional languages. Instead, Go code implementation is spread over multiple source files, tens of source files, or even hundreds of source files, perhaps in multiple folders or subdirectories, and each of them with readmes that will eventually lie to you. So, how do we make Go implementation more like Jupyter Notebook style documentation? We need to link intent, our documentation intent, with the code implementation. So what if you can have a product that can pull in the implementation? You decide what you want to document, the sequence of how you want to document it, and then let the code speak for itself. Good news. This tool exists today, right now. In fact, you're looking at it. It's called Go Present. Let's talk about Go Present. Go Present is a Go tool, so you need Go. Just download Go. It's a straightforward install. Then, as in GoDoc, go get Go Present. That's the command. And include it in your path, something like this, and run it. Normally, you just type present, but because I'm running my presentation inside the container, I have to do this extra incantation. And I've actually already run it. Let me show you this thing over here. Lots of warnings. I have to run it, otherwise you don't see this slide presentation. So Go Present has two personalities. The slide personality or the slide format, which is what you're seeing now. It presents information in slides, in chunks, where you can go forward and you can go backward and you can go forward again. And more relevant to my topic today, it can present your code in a long-form article format. And I've written such an article. It's called my.article. Let's click on this link. Let's go through this, shall we? Documenting with intent and implementation by me, of course. So, command example GoDoc shows GoDoc's failure to document main functions. This is my documentation intent. And this thing, I did not type it in. It is pulled from the source code itself. But notice, there's no import, there's no package main. It shows only what I feel is relevant to show. So it doesn't clutter my documentation. Not like diving into the source code itself, where you have to hunt for things. Now, obviously, when somebody reads this, I've got this a func, seems important. It's a private function. hey, it's down here. Okay, and what does it do? Oh, it does that. And there's also this my package, capital A func. I don't have to switch tabs. I don't have to click on links. Why? I don't have to go to go.doc. Why? Because it's right down here. I intend to document it. So my package A func is down here and it does that. And again, this is directly from the code. So my second intention was for my second example, that's why it's 2. It makes clear what my package.app does. Okay, I've got this funny main function and all it does is call my package.app. But straightforwardly down here, my package.app does these 2 things. And those 2 things are shown here. The beautiful thing about the article format is it gives you a table of contents which is clickable for free. Let's look at A func. Boom, A func is here. Very nice. I love it. This has actually been put forward together with slides since the very beginning of this tool, but nobody has used it for code walkthrough documentation like this, other than the Go authors themselves. So I learned from the geniuses who wrote Go. Now let's talk about testable documentation. How can we test our documentation? Well, the Python guy says there's this thing called doc test. I'm not talking about this. Actually, I'm talking about code getting refactored all the time. Well, at least code should get refactored all the time. And a very, very powerful refactoring technique is to rename functions to better reflect their intent. So let's go and rename a func to something, well, I hope clearer, a function. And it's in example go.doc, main, etc. So let's go to my editor. Example go.doc. Yeah, there it is. Let me turn on numbers. What was I supposed to rename? A func. Okay. So I go to the A func, go rename. What do I want to rename it to? Function. Okay. Enter. It does its stuff. Notice something. The comment also got renamed, and this got renamed. Let's see whether it builds. Go build. It's good. Let's see whether it tests. It's good. Well done. We have properly refactored our function. Now, let's go back to our article. Everything's still okay, but still a func. Oh, I need to refresh. Press F5 on my browser for refresh. Bang! Something went wrong. My article is broken. Okay. Let's look under the hood at the source. Okay. Let's go back here. Sorry for flipping back and forth so much. It says my doc article line 10. Let's look at that now. My doc article, I turn on numbers again. Line 10. Okay, line 10 is here. So now you can see the power of the article format. This is a header. It looks like Markdown. And it pulls in the code using this directive, .code directive. And it's pulling in from that file. And it's looking for start of line, function. Function followed by a opening bracket. So if this regular expression fails, this article will not render. That's the problem. So, okay, let's go back. I'll refactor this back. Go rename. Back to a func. Yeah, it's now refactored back to a func. Now I press F5 on my browser, and it's back. So that is actually how we can test our documentation. When key function names change, our article, or I like to call it my code walkthrough, will fail. So the code walkthrough will fail, and it forces me to either fix my function or, more often, fix my documentation. It forces me to update my documentation because it failed the test. Good. So we've reverted the name and it works again. And we have seen under the hood. So the Go present source is essentially an extended version of Markdown. It's actually Markdown with some extra commands. You've already seen this command. It's the code directive. It pulls in the file name. There's a start regular expression and an end regular expression. There's also something super powerful for Go code. Actually, it's not only for Go code, but for Go code, you can just say play, the name of the Go file, start and end, and you will actually execute that code in your presentation or in your article or in your code walkthrough in line. And you can edit it as well and change variables. Extremely powerful. But I want to say this is not only for Go code. Filename.go Go can be replaced by any executable and it will work. Similarly, this file need not only be for Go code, it can be for any source code. Notice I just say file name and not filename.go. It can be for any source file. We like images, we like pictures, so we can pull in PNGs, we can pull in JPEGs, we can even pull in movies if you want to. And we can specify the height and the width, and we can default to a maximum screen height, etc. And finally, in my next slide, we can demonstrate the use of links. Well, this is a link. You can click on it, and you can get the slide and the My Doc within, by clicking on it within the slide itself. And lastly, a plug for my current employer. Xendit is hiring. If any of you are interested in working in exciting Go projects, please send in your application and your resume to this email address and mention the two teams I'm managing: Ops Automation, we automate operations, and Engineering Operations. And that brings me to the end of my talk. And let me go back to the primary screen so that I may address questions and answers. I'm switching to my primary screen now.
Wow. Okay. Thank you, Siu Yin. Thank you. Thank you for the sharing. I am
You're welcome.
personally so. Wow, it's really nice. Really, really nice. Okay. All right. Let's see if there's any questions for this particular topic. Okay. Didn't see any questions. All right. I think I'll share the links to the GitHub on the code itself to take a look, take it for a spin, and you should really try this. Wow. Okay. Have you ever tried this on other non-Go code bases already?
Yeah, actually, it works on any source code base. It works on TypeScript. It works on Node.js. The code directive will pull in any source file. It doesn't even have to be a source file. It could even be a README file. So the people who wrote Go Present, well, most people use it for presentations. But there's the second personality, which I think is underused, and that is the article format. which is excellent for code walkthroughs and excellent for this kind of documentation. Jupyter notebook style documentation, I like to call it.
Yeah.
Well, anyway,
Okay.
I hope you learned something useful, and I enjoyed presenting.
Definitely. Thank you, Srin. Thank you. I think there's no questions so far.
No problem.
All right. All right. Thank you very much. So I've come to the end of today's. I don't know whether is Rodolfo still here?
Yeah, I'm here.
Want to say some
Eh,
closing words from Go Mexico?
Thanks for collaborating with us. We expect to collaborate again in the future, so we can have more Go talks. So great talk, Siu Yin. So yeah, everything for us. Thanks for watching.
Thank you very much. Thank you very much. Thank you, Rodolfo. Thank you. All right, guys. We've come to the end of today's session, Saturday. Hold back a weekend. Thank you very much, and hope to see you in March. And just closing notes from GoSG. We always are looking for speakers. Do come to us in our meetup board or ping any of the organizers directly if you want to submit a talk. We also have a link for that, submitting of talks. In March, we are collaborating with Google DevSpace again on International Women's Day. There you see on the screen is the QR code for submitting any talks that you like to GoSG. In March, we are going to collaborate with Google DevSpaces on International Women's Day. So we're also looking for Golang speakers, women speakers who wish to share about Golang topics. So yeah, let us know. And we also welcome Go Mexico. If you have any female speakers who would like to attend a day, it's going to be on 20th of March. It's again another Saturday morning, right? And I look forward to collaborating with you guys. Thank you. Thank you again, guys. And that's all.
Thank you.
Enjoy your weekend. Thank you.
Thank you,
Thank you,
everyone.
Srin.
Bye.
Bye then.